Sometimes an entire industry changes because someone proves there is another way to reach the same destination. That is why people started talking about a deep R1 moment. It was not simply about a new chatbot appearing online. It was about challenging a growing assumption that only the largest technology companies, with enormous budgets and massive computing resources, could build state-of-the-art reasoning models. Whether every early claim surrounding the model turned out to be perfectly accurate mattered less than the larger message. Suddenly, people everywhere were asking a different question. What if advanced AI could become much cheaper, much more open, and much more competitive than many expected? To understand why this mattered, it helps to look at where the AI industry had been heading. For several years, progress appeared closely tied to scale. Bigger data centers, more powerful graphics processors, larger research teams, and higher training costs seemed to produce increasingly capable models. Every major release appeared to require even more computing power than the one before it. This created an impression that only a handful of organizations had the resources to stay at the frontier. Then DeepSeek released R1. The model demonstrated impressive reasoning capabilities and was made available in ways that allowed researchers and developers to study, use, and build upon it. Almost immediately, conversations spread across the technology world. Investors reacted. Engineers began testing it. Researchers compared results. Companies started asking whether their own development strategies should change. The phrase deep R1 moment began appearing because people saw parallels with other moments in technology history. Sometimes an industry spends years assuming one approach is the only practical path forward. Then a newcomer demonstrates a different combination of engineering decisions, efficiency, and openness that changes expectations overnight. One of the most important ideas behind R1 is reasoning. Traditional language models are very good at predicting the next word based on everything they have already seen. That allows them to answer questions, summarize documents, write stories, and translate languages. But reasoning models aim to perform better on problems that require multiple logical steps. Think about solving a complicated math puzzle. The answer is not usually the difficult part. The difficult part is finding a reliable sequence of steps that leads to the answer. Imagine asking someone for directions through a complicated city. One person simply says the destination is 20 minutes away. Another explains which streets to avoid, where traffic usually builds, when to turn, and why a particular route is better. The second answer reflects a deeper planning process. Reasoning models try to improve that kind of structured problem solving. This does not mean they literally think like humans. Artificial intelligence does not possess human consciousness or understanding. Instead, these systems are trained to generate patterns that often resemble careful reasoning. Even so, improving those patterns can make the models significantly better at coding, mathematics, scientific questions, and other tasks that benefit from logical consistency. Another reason the release attracted attention was efficiency. Training modern AI systems is extraordinarily expensive. It requires enormous collections of data, specialized hardware, electricity, cooling systems, and months of engineering work. Because of those costs, many people believed the barriers to entry were becoming higher every year. DeepSeek challenged that narrative by showing that engineering improvements and different optimization strategies could produce impressive results without simply throwing unlimited computing power at the problem. Think about two cars that reach the same destination. One burns twice as much fuel as the other. Both arrive, but the more efficient design changes how everyone thinks about transportation. Suddenly, engineers start asking not only how fast a vehicle can go, but how efficiently it can get there. That same shift happened in AI discussions. Instead of asking only who owns the largest data center, people increasingly asked who designs the smartest training methods, the best optimization techniques, and the most efficient use of hardware. The open nature of the project also played an important role. Many powerful AI systems remain largely closed. People can use them through online services, but they cannot freely inspect much of what is happening behind the scenes. Open models create a different dynamic. Researchers can evaluate them, developers can adapt them, universities can study them, and businesses can customize them for specialized tasks. Imagine two scientific discoveries. One remains locked inside a laboratory where only a few people can examine it. The other is published so thousands of researchers around the world can build upon it. The second approach often accelerates innovation because improvements come from many independent teams instead of only one. That does not mean open models are automatically better. Closed systems can sometimes offer stronger safety controls, better support, or higher reliability. But openness expands participation. Smaller companies, independent developers, and academic researchers gain opportunities that might otherwise be unavailable. This broader access explains why the release sparked excitement far beyond AI researchers. Businesses began wondering whether they could reduce costs. Software developers explored whether advanced reasoning could be integrated into products without relying entirely on a single provider. Governments and universities considered what greater access to capable AI might mean for education, research, and national competitiveness. Financial markets also paid attention. Technology investors constantly evaluate whether existing assumptions remain valid. If powerful AI becomes less expensive to build or deploy, that changes expectations about infrastructure spending, software development, cloud computing, and even hardware demand. Markets often react not only to what has happened today, but also to what could happen over the next several years. Still, it is important to separate excitement from exaggeration. Some headlines suggested that one model had suddenly made every competing AI system obsolete. Reality is more complicated. Artificial intelligence develops through continuous improvement. Every major laboratory studies new techniques introduced by competitors. Strong ideas spread quickly. Today's innovation often becomes tomorrow's standard practice. History provides many examples. Internet browsers competed by adopting one another's useful features. Smartphone manufacturers continuously borrowed successful ideas. Programming languages influenced each other. Scientific progress rarely belongs permanently to one organization. Good ideas travel. The same pattern is likely in AI. If one research team discovers a more efficient training strategy, others will investigate similar concepts. If another laboratory creates better reasoning methods, competitors will attempt to improve upon them. Innovation becomes cumulative. Another misconception is that reasoning models eliminate hallucinations or factual mistakes. They do not. Even advanced systems can confidently generate incorrect information. Better reasoning reduces certain kinds of errors, especially on structured tasks, but it does not guarantee perfect accuracy. Human oversight remains important, particularly in medicine, engineering, law, finance, and scientific research. The Deep R1 moment also highlighted how quickly the global AI landscape is changing. Artificial intelligence research is no longer concentrated in only one region or one group of companies. Talent exists around the world. Universities, startups, established technology firms, and independent researchers all contribute new ideas. Competition has become international, and that competition often accelerates progress. For everyday users, the impact may appear gradual rather than dramatic. You may notice AI assistants becoming more accurate at planning, coding, writing, tutoring, and solving complex problems. Businesses may gain access to capable models at lower costs. Educational tools may become more widely available. Developers may have more choices instead of depending on a small number of platforms. For researchers, the implications are even broader. Lower costs can allow more experiments. More experiments often lead to faster discoveries. Faster discoveries can improve efficiency again, creating a cycle where progress feeds additional progress. Perhaps the biggest lesson is psychological rather than technical. Before DeepSeek R1, many observers believed the future belonged almost exclusively to whoever could spend the most money on computing resources. After its release, the conversation shifted. Efficiency, clever engineering, optimization, openness, and research strategy suddenly became central topics alongside raw computing power. That shift does not mean computing resources no longer matter. Advanced AI still requires enormous amounts of hardware and energy, but the industry increasingly recognizes that intelligence comes not only from bigger machines, but also from better ideas. Looking ahead, there probably will not be one final winning AI model. Instead, we are likely to see continuous competition among many organizations, each introducing new techniques that push everyone else forward. Some will focus on reasoning. Others will prioritize speed, efficiency, multimodal understanding, scientific research, robotics, or specialized professional applications. In that sense, the Deep R1 moment is less about one specific model and more about a turning point in expectations. It reminded the technology world that breakthroughs do not always come from spending the most money. Sometimes they come from rethinking the problem itself. And when that happens, the entire industry is forced to reconsider what is possible, who can participate, and how quickly the next wave of innovation might arrive.